In this video, I'll cover the solution to the 2005 Aime number 6. Let p be the product of the non-real roots of x to the fourth minus 4x cubed plus 6x squared minus 4x equals 2005. Find the floor of p. If you haven't seen this problem before, feel free to pause the video and attempt the problem before listening to the solution. So first of all, what are roots? Well, roots are numbers that make this equation true. So that means if the root is a, then I can plug in a to the fourth minus 4a cubed plus 6a squared minus 4a is 2005. And so for this polynomial, how many roots are there? We can tell by the degree of the polynomial. The highest power is x to the fourth, so there are 4 roots, a, b, c, d. Since we're asked to find the product of the roots, what might come to mind is Vieta's formulas. Vieta's tells us the sum and product of the roots. The sum is going to be the negative of this coefficient, so it's 4. And the product of the roots is going to be negative 2005. Although we know the product of the 4 roots, here's the problem. We want the product of the non-real roots. So of a, b, c, d, which ones are real and which ones are not real, right? That's something that Vieta's cannot tell us. Let's keep Vieta's in the back of our minds, but it seems like we need something more from the problem before we can solve it. If I look at the coefficients of this polynomial, and if I just ignore the negatives for now, I see something that looks like 1, 4, 6, 4. Doesn't that look like 1, 4, 6, 4, 1? This is coming from Pascal's triangle, and that's row 4 of Pascal's triangle. What is Pascal's triangle used for? One use case is it's used in the binomial theorem. So you'll notice if you take x plus 1 to the fourth power, it becomes x to the fourth times 4x cubed plus 6x squared plus 4x plus 1. All the coefficients are just this row of Pascal's triangle. This polynomial is very close to the one above, but it has a negative here and a negative here. So how do we deal with that? We can actually tweak this. We can make x minus 1 to the fourth to get x to the fourth minus 4x cubed plus 6x squared minus 4x plus 1. And that will actually pretty much greatly simplify this problem, because if I just add 1 to the left and right hand side, then I know that the left hand side collapses into this expression. The left hand side is going to be x minus 1 to the fourth, and the right hand side is going to be 2006. Now, in order to solve this, we can break it into 2 cases. When I take the square root of both sides, I know that x minus 1 squared is either going to be 2006, or x minus 1 squared is going to be negative root 2006. If I'm to take the square root of both sides, in this first case, I'll get x equals 1 plus or minus the fourth root of 2006. And these are 2 real solutions. That means the other 2 are probably going to be the unreal roots. And if I scroll down and I take a look at this solution, what if I take the square root of both sides? Then on the right-hand side, I have the square root of a negative number, which is imaginary. So that means x equals 1 plus or minus an imaginary number. And that's going to tell me, okay, this is going to be the 2 non-real roots I'm looking for. Instead of actually solving for x and then multiplying the 2 non-real roots together, we can use Vieta's formula as a simplification. So let me expand this polynomial, x squared minus 2x plus 1, and then I'll add the root 2006 to the other side. Vieta's tells me that of these 2 non-real roots, the sum of the roots is going to be 2, and the product of the roots is going to be 1 plus root 2006. And now all we have to find is the floor function of 1 plus root 2006. The floor function just means the greatest integer less than or equal to this quantity. So I can move any integers out, and I can find the root 2006 and take the floor of it. We can think that 40 squared is 1600. 50 squared is 2500. So root 2006 is somewhere between 40 and 50. So we try the midpoint. 45 squared is 2025. We can try 44 squared. And that'll give you 1936. So since 2006 is in between 1936 and 2025, we know that square root is 44 point something. So I'm going to have 1 plus 44 on this side. The floor of P is equal to 45. With that said, I hope you found this video helpful and informative. If you have any questions, feel free to leave me a comment down below and I'll do my best to get back to you. Thanks for watching, and I'll see you in another video.